Alright, hi, my name is Excel, and we are the VR Melanoma Simulation Group, and this is...
Peter.
Alex. Richard.
Brandon. Ellery.
Cool. Alright, so our project for this capstone is sponsored by Dr. Amit Sharma. He's a dermatologist from the Mayo Clinic, and he wanted us to connect gamified elements and virtual reality tools to make an educational tool that will help medical students teach them what is melanoma and how to identify melanoma.
So as an introduction, melanoma is a type of skin cancer that forms around moles, which is oftentimes a troubling issue, mainly because moles, when they become skin cancer, sometimes you look at them and you just decide, well, this still just looks like a mole. So many people are unable to detect this. This is very common, especially in the medical field, where they only spend a few hours discussing it in coursework. So as a result, this project with the VR simulation will allow medical students as well as doctors to simulate examining moles and determining whether they are melanoma or not. This is a big, important issue because melanoma is considered one of the biggest skin cancers and killers.
Okay, so in order to do this, these are the requirements we set out. So we have 6 main requirements for our application. The first is that it's going to be virtual reality using Unity and Vive. So it's going to be for Windows. And the main thing with virtual reality is that it's going to be first person. So that's going to increase the immersion. So now when a medical student is going to use our application, it's going to feel like they're doing it almost in real life, as opposed to, say, reading it in a textbook or looking at a PowerPoint slide. This is something they can interact with. So it's going to simulate this real environment as close as possibly. So next, we're going to have the requirement of having room scale movement. So that's the important thing of using the Vive. So the Vive is a certain type of virtual reality headset that lets you move around a room and around a 3 meter by 3 meter area. And it records the area where you are in the room. So you can actually walk around the game and it'll feel like real life. So this is definitely something that's going to increase the immersion and make it more entertaining, make it more realistic, and keep their attention. So the next requirement that we have is having a zoom exploration. So if you don't know, a dermatoscope is something that dermatologists use to examine moles closely to determine whether or not they are melanoma or different types of moles. So we have this implemented in our game, and that's what's going to be used to allow the user to zoom in into a mole on the human body that we'll have in the room and determine if it's melanoma. So this will be very realistic. You can literally see it zoom in the game, so we're trying to make it as close as possible to reality. So in order to actually implement all of these features together, we're going to have 2 modes. One is the learning mode and one's the play mode. So the learning mode is going to teach the users the different types of melanomas, the different types of moles, so they can determine whether or not what they're seeing is actually melanoma. We want to tell them the ABCDEs of melanoma, and use the skills and the teaching methods that Amit Sharma, our sponsor, is providing to give them a better understanding of how to detect melanoma. The play mode, on the other hand, is going to be around 3 levels, and it's going to have between 5 to 20 moles per level that the user has to detect and determine whether or not it's melanoma. And as the levels go on, they're going to get more difficult, and there's going to be more moles per level. And we're going to try to introduce some complexities to keep the game both interesting and educational. So they don't just do the first level and find it's easy. They can continue learning and have an upward trend in their growth. So those are the main requirements that we have, and that's what we hope to implement by the end of next fall.
Alright, so to make this game, we made many use cases just to describe what we want to make. So the main use case that we have is we have an actor, and the actor is going to be a medical student because that's going to be our main audience. So the name of this specific use case is determine if mole is melanoma, since that will be a core feature of our game. So a description of this use case is a medical student has a virtual dermatoscope, and they want to be able to zoom in on a mole and then see if they want to biopsy it if it's melanoma. So the story, we put it all together in one sentence, is as a medical student, I want to be able to zoom in on a mole so I can analyze it and determine if it is melanoma. Alright, so we're going to have a visual representation of this. So the stick figures are the people and the systems that we have in place. So first off, we have a system, a mole database. Right now, we are still determining what database will be the best, what kind of file storage that will be. So that database will have all the moles, and that database will send over to our human object to have the mole be able to be seen on our human object, and then our medical student can, from that human object, examine it. So if you see that circle, it can examine the mole, and then from that examination, that medical student can choose whether they think it's melanoma or not. And then after that happens, it will be sent and will update information on the scoreboard to see if they were correct or not, and update all the information there.
Okay, so for our proposed solution, during this semester, we created a functional prototype that pretty much has a dermatoscope with almost zoom-in functionality. We also have a human model with textures, skin. You see that in the gameplay prototype that we're going to show you soon. And we also have moles that you can identify with the dermatoscope. We decided to make a functional prototype for our first stage during spring because of the fact that we want to focus on making it work in a VR simulator environment first. The stages that we were talking about with Ricky, like the learning and playing mode, we'll be working on those in the fall, and that's what will be our full, complete state of the game. So we're going to show you the demo, and we hope you like it.
Alright, so here's the demo for our game. Right off the bat, on the right you can see Alex wearing the Vive, and on the left is the game. As Alex moves his head around, so does the character in-game. This really simulates the realistic movement that we wanted to give to the medical students who will use this tool. It's to make sure that what they're working on in the game mimics what they're going to be working on in real life. Alright, so we're going to keep going with the demo. You can see Alex holding the dermatoscope on his right hand and one of the Vive controllers on his left. So when we were designing the game, there were some restrictions that we found. Although the game is room scale, meaning you can move around in a room spaced area within the game, it still doesn't take into account movement. Players can't move a certain amount of distance, and so in order for us to kind of tackle that challenge, we developed a teleportation movement. So in order for a player to move, they press a button on the controller and they teleport to that spot. We're going to limit how far the player moves inside a room, but it's still important to have that functionality because we can't fit everything in just one room in our game. Alright, so you can see Alex moving around, getting used to that teleportation mechanic, and just checking out how the room is laid out. In a bit, we'll see that Alex will encounter a board, and this is another part of the user interface that we talked about earlier. So as the player goes around the game, plays it, he can keep track of his progress through this user interface. When he finishes a task, or when he finishes tutorial, he can go to this board to look up the melanoma information that he has just discovered. It's a way for the game to reinforce concepts that they might have not remembered right then and there. This was a concept introduced to us by our sponsor, Dr. Sharma, because the students can't really take off their headset to check their notes, so they need a place to be able to check what they've finished and what they've done. So here you can see Alex get close to the patient. This is where most user interaction is going to be. As the medical student learns melanoma, he can use the dermatoscope that we've developed to look into the skin of the virtual patient and decide whether or not they have melanoma. And this is how most of the game is going to be. As they get it correct and as they learn more and more and it gets harder and harder, they earn more points and they get more references that they can see in their board. So that's about it for the demo. I'm going to hand it over to Brandon to tell you what the development is going to look like for the rest of this semester and for the rest of the next semester. Thank you.
Okay, so in terms of what we have completed for this semester, we set out a specific set of goals that we wanted to have done. Basically, we wanted to train the entire team on VR and Unity. We had basically only 50% of the team knowing or having working knowledge in Unity, so the first thing was to get us all up to speed and get us working knowledge to all contribute onto the project. We wanted to design a basic prototype and the game design document, basically telling how the game will be run, and it's dictating how the game will interact with itself as well as the player. In terms of modeling for the game, or bringing physical objects and basically putting them into the game world, into the player space that the player can interact with. We have the player hands done. We have the human with several moles on it. And we have the dermatoscope, which is the main tool the player will be using. In terms of game functionality that we have done at this moment, the player can explore the player space we've created for them, and they can basically interact with any of the objects that have been aforementioned. What we're currently working on is the pop-up GUI, which is going to be the main interaction between the player and the game in terms of teaching them what melanoma is, how to detect it, and basically just the entire learning experience of the game. The user we want to implement the ability for the user to guess. We need to still implement the actual game functionality of the game, the actual guessing portion of it. So it will basically, the game will run through the tutorial with the player, and then from there the player will be able to basically get a couple rounds of practice in, and then that's when we introduce our level progression system, which is going to scale. It's going to scale as the player progresses, just to hammer in more of the concrete elements that we want to teach, rather than just have them guess, hey, is this melanoma, let me just quickly guess, get this over with, and then leave. We'd rather teach them more of the memorization skills for longer term memory. And then for our timeline for the fall, we want to have a variety of mole locations on the human model. We want to basically randomize the algorithm that will place moles on the human body, just to make it more realistic, more replayable, just so a user that has played the game or has played it long enough can't just immediately know what state the game is in and just go from there, just guess based on meta-knowledge rather than knowledge from melanoma. We want to implement different levels of control. We want to have more interaction between the player and the what's the word I'm looking for?
The different modes? The dermatoscope?
Yeah. So we want to implement more interaction between the player and the dermatoscope, like more functionality from the dermatoscope, basically implementing how it would work in the real world. And then it's still up in the air, but we want to figure out if we want to implement the game to work in VR as well as on a computer or with a controller, or implement both of them.